All right. So I think I was told that one of the most useful things that sort of this group of people who widely disagree with each other in some sense, one of the most useful things I can do here is sort of lay out an alternative vision for AI safety. So when I talk about AI safety, what is it that I mean? Like, why do we disagree so much? And so the next 8 minutes, in a typical academic fashion, I have a PowerPoint slide that I want to share with you. In sharing my vision for what I think AI, the future of AI looks like, what we need to be concerned about, and most importantly, what are policy prescriptions we can agree on, even if we disagree on our predictions about the future. And as expected, the pointer has stopped working.
I can do it. That's better for you.
Oh, yes, please. Thank you. All right, so I want to start with a distinction between 3 different types of things when we talk about AI, which is, when are we developing AI methods? When are those methods being turned into applications that are being sort of being used in the real world? And when are those applications being adopted across society? And I want to start with the last step of this, which is AI diffusion across society. And I want to argue that, in many of these areas where there are safety issues or safety burdens, the state of the art of what we are adopting for AI today is decades, not years, not days, not weeks, not months, but decades behind the state of the art. So in particular, an application of AI that is very widespread today is predictive AI. This is AI that's used to make predictions about people's futures, and on that basis, make decisions about them. We have AI systems that are being used to make decisions about bail hearings, about which candidate should be hired for jobs. And the systems we are using here are 50 years old. So we're using 50-year-old linear regression methods. And when people have tried to update these methods to new variants of AI for making these safety critical decisions, there has been a lot of pushback from civil society, from researchers, from ourselves, because in large part because of the inscrutability of these systems. A similar case, I think, holds for self-driving cars. If companies were not averse to liabilities, already self-driving cars are in a position where we could deploy them much more widely than they are deployed today. And it is only because of the risk tolerances of these companies is slower that we've seen progress being slower. And a third example is medical AI devices, where once again, we have the capabilities today to drastically change healthcare when it comes to using AI tools. And yet we will take a process of like years or decades to adopt these systems into critical infrastructure because we realize the importance of safety in these domains. And I want to argue that when it comes to evaluating AI, we need to focus a lot more on this layer of the stack to evaluate the societal impact of AI. So these are the 3 types of sort of dimensions of AI use. The first is inventing new AI methods. Here you have metrics like benchmarks. I do expect that AI will continue to crush all of these benchmarks, frontier math, SWE-bench, core bench, all of these benchmarks for measuring research capabilities. And that's all great. But my argument is that this does not translate to impact in the real world. To measure how well we are innovating with AI, to measure how well AI applications work, what's actually more important is uplift studies of like people using these systems in the real world. And at the level of application, at the level of how well these applications are sort of diffused into the real world, it's still not enough to conduct uplift studies of what could have happened, but rather our focus needs to be on diffusion. And these 3 things operate at very, very different timescales. So if you look at AI progress on benchmarks, that does not tell us how important AI is in the real world, either from the perspective of like how well humans can already use it, or how well these tasks can already perform at human level equivalence, or in terms of how well these systems are being diffused in society. Next. And so my argument here is something like this. So when we sort of think about AGI as being this one point where we sort of can automate anything a human can do, we are both overestimating and underestimating the impact. We are underestimating the impact because transformative AGI is not necessary for a large number of AI applications and for diffusion of these applications across society. It is not necessary. In fact, even if we continue to have like progress at the level we are today, if we stop sort of at GPT-4 or O1 level systems, we still have a large number of applications that have just not been built today, that have just not been sort of evaluated and haven't, as a result, been diffused across society. Sorry, just the previous one for one more minute. And at the same time, I think it overestimates the impact, or looking for AGI overestimates the impact, because when we have this notion of this one single point where AI can recursively self-improve or whatever, I think the issue is that that is not how progress really works. If you want to develop an application that can self-improve in the sense of becoming a better self-driving car, then you actually need to put this application onto the roads. And that's why we have many sort of safety guardrails or safety breakpoints which are not possible to automate. So sure, we can have AI systems that well outperform today's AI systems. We can keep having these improvements in a certain small number of domains, which you can run simulations on, or you can build verifiers for. But that is not everything in the real world. In fact, I would argue that that is not most of the applications in the real world. Most applications of AI fall out of the categories of AI methods improvement that we can automate and recursively self-improve in this way. One last thing. and finally, I want to argue that automation in this way also reduces the value and cost of doing certain things. So maybe like the trajectory that I'm trying to imagine here is, let's say AI does do a lot of the tasks that a PhD student would do today much better than they can. This is the same exact situation that we are in today. If you compare like a CS PhD student today to someone in the 1960s, the amount of code productivity that the PhD student has today as a result of being able to code in Python rather than on computer systems that require binary inputs is of the same amount. And so the fact that we can write computer programs more quickly is something we've already been doing, and the result of that is more and not less requirements for human interventions at various parts of the research progress. In other words, once the value or the cost of something drops down, we simply move on to bigger things or projects that are sort of more productive in some sense, but that still require human intervention. So what might this intervention look like? My next argument is that over the next few years, as we start to see more capable AI systems, a lot of the innovation that we see both with these systems and in society more generally would be on control. So this is, how do you control existing AI systems? How do you sort of control them, whether it is in a given application or a given domain? How do you develop mechanisms to have reasonable oversight? And I think what we're calling control today is sort of like unimportant or underemphasizes the nature of this. I think like the word control is too sort of broad to describe this category of jobs that I'm imagining, because you would sort of have new jobs of like safety engineers who are doing all sorts of new things that we can't imagine in our present position today, simply because we don't have access to these advanced systems. But just like with the Industrial Revolution, you had a lot more focus, especially with the introduction of factories, on workers who work in these factories with oversight over the systems. That is the sort of transformation I'm thinking about. And primarily, this is like a second order bit to this, primarily this would be driven by market forces because the risk tolerances that companies or corporations have for releasing unsafe AI into the world are too high. So the first notice of accident, you would get into sort of places where it's just not profitable enough to release these systems into the wild. In fact, one example of this is we have already seen Microsoft wanting to release a version of Copilot that allows these systems to take arbitrary actions on the computer. And essentially, this was blocked because of like the lobbying efforts or the sort of outrage by many people in the security community who pointed out that this is giving unrestricted access to any website that a computer visits. So what does all of this mean for policy? So I think I want to make 4 points before heading into where we have sort of agreements and disagreements. The first is, if AI continues to be a normal technology in this way, it is still transformative. By normal technologies, I don't mean this won't have an impact on the GDP or whatever. Even the internet or electricity is a normal technology in this view. If we still go along this path of AI as normal technology, the question around concentration and decentralization becomes a lot more tricky. So on the one hand, if we consider superintelligence as a risk, we might think concentration is the way to go so that we can shut it down. On the other hand, if we think AI will proceed as a normal technology, decentralization might be the way to go to avoid concentration of power and all of the effects of capitalism as we have seen with platform capitalism. So here's where I think there is common ground, irrespective of whether you found my pitch convincing. I think policies that focus broadly on societal resilience, that everyone can agree on, irrespective of whether we think superintelligence is a real threat, include building tech expertise in government, transparency, post and pre-deployment monitoring, whistleblower protections for people inside AI companies, safe harbors for AI researchers, using AI for defense, so for example, for cyber or biosecurity defense, improving the literacy that people have when it comes to using AI, and finally, investments in democracy to enable more productive discourse around this technology, irrespective of whether we get to the point where AI is super intelligent or human-like. And I think all of these are interventions that all of us in the room who care about AI safety should be on board on. And my argument is, irrespective of whether you found the previous parts of this convincing, this is something we should actively be pushing for. On the other hand, there are some interventions that are only useful if we end up in the world where AI is a normal technology, such as including or improving competition between model providers, including through open models, as well as making AI widely available so that low resource actors who otherwise would not have access to these models can use AI for defense. And with that, I'll end.
Great. So now Daniel is going to get an equal amount of time, and Daniel doesn't have to respond to those points. He's just his show. He can ask, he can talk, and then after that 10-minute period, then we'll just move into a broad discussion.
Thanks. First of all, it's exciting to talk with you. Thanks for coming here and saying all these things. I'm excited to get into it. I have lots of questions and thoughts. I'm here substituting for Ajay Kuntra, so I don't have slides prepared or anything like that. I'll just give a very, very brief overview of my views, which can be placed in contrast with yours, and then maybe I'll ask some questions, and then we'll just see what happens. So here is a little sci-fi scenario, which is sort of like my median projection of roughly how this is going to go. Sometime in the next few years, maybe in 2027, maybe in 2026, the sort of AI agents that Anthropic and OpenAI are working on will start actually really working very well. And so you'll have a computer using LLM-based system that can basically just use a computer in the same way that you would, and is good enough at doing a wide enough range of tasks on that computer that it can basically substitute for a research engineer at a top lab. And probably also substitute for all sorts of other jobs or tasks around the economy, although probably not everything, at least not immediately. That begins to accelerate the course of AI research, and shortly after that, maybe 6 months after that, you have the complete loop closed. So you have all the research scientists, all the research engineers, all the employees who are driving the core research at the company are now sort of redundant because everything that they were doing or can do, the automated AI system can just actually do better and faster and cheaper. Then there's a further acceleration in progress, and maybe that initial system by itself wasn't AGI, but because it's so good at AI research and because the pace of research is now going very fast, you can quickly develop AGI. Specifically, like whatever skills it was lacking that caused it to not count as AGI, because it's so good at AI research, it can do development research to figure out how to get those skills. And so then now you have AGI. What is AGI? AGI is a system that is a drop-in substitute for a human remote worker at any profession. Or maybe another definition would be it's a system that has all the cognitive skills of all the humans that matter, or something like that. So for any particular task, any important skill, it is as good as the very best humans at that skill. Of course, maybe I say cognitive, maybe it can't dance if it doesn't have legs. So I'm sort of excluding the physical stuff, but all the cognitive stuff, it's as good as the very best humans. That's the definition that I think. Beyond that, superintelligence. So I don't think progress is going to stop there. Beyond that, you get to systems which are like that, but even better. They're not just as good as the best humans, but they're like importantly better at least a huge range of possible things, including things like persuasion, strategy, hacking, all sorts of things, right? How many of them will there be? Well, it's not exactly an apples-to-apples comparison because it's copies of models running on data centers producing tokens and stuff, but you can maybe visualize it as something like an army of about 1 million of them running in parallel, and maybe thinking at something like 10 to 100 times human speed. That's like the technical story. And then there's like the political story of like, well, what happens after that? And like, how does the world change? I actually totally agree that there'll be a very slow, like by the time when this is happening, the world will look basically the same as it currently looks because of a lot of the frictions that you were just talking about. I think that there'll be this army of superintelligences in the data centers, but we'll still be driving regular cars, not self-driving cars. Like it'll still look pretty similar. And they'll be bottlenecked on compute to like actually, automate. They won't be actually automating the jobs in the economy because they'll only have 1 million of the superintelligences. They won't have 1 billion of them, for example, or something like that, right? Then I would say, if things go well, we will get something like what Dario Amodei, CEO of Anthropic, describes in his essay, Machines of Loving Grace, where you get, he says we'll get like a whole century's worth of technological and economic progress compressed into like a decade. I think it'll be compressed more than that, like maybe into like a few years, and probably more than just a century's worth of progress, maybe something like all the progress you can possibly imagine happening and then more happening in the decade, or something like that. But so I do disagree with him quantitatively about how fast it will go, but roughly speaking, it's at least directionally correct. You have a lot of technological progress, a lot of economic transformation. It won't happen instantly, but it will happen quite fast by historical standards, I think, because the superintelligences will be directing all of it and helping make it happen faster and providing excellent advice on how to reform the laws and how to cut the red tape and how to build the new factories and so forth, and telling people exactly what they need to do to make it happen fast. And in the good world, all of that goes splendidly, and everybody, poverty is solved, no one needs to work anymore, everyone's taken care of, cancer is cured, all that stuff. However, I'm concerned that the good world is not what we will get by default. Two things I want to mention. One, alignment problem. Two, concentration of power problems. So alignment problem would be this army of superintelligences. Is it actually aligned? Is it actually loyal? Somewhere there'll be a document that's like, this is the spec. These are the goals that our AIs are supposed to have. These are the principles that they're supposed to obey. These are the tasks that we're giving them. Will they actually have those goals, or will they just be pretending to have those goals until they are deployed widely throughout the economy and don't have to obey the humans anymore, right? This is a technical problem, and I'm worried that we don't have a solution to it yet. There's a lot of people working on it, and I hope that they work faster and harder and with more funding, because they really need to nail this down. There's a lot more to say on that, but I'll move over that for now. The last thing I'll say is that I'm also worried about the concentration of power risks. So I think that even if alignment turns out to be easy, you still end up in a situation where you have probably a single company with this army of superintelligences. And there are other companies that are trying to do this, but they're typically like, I think the typical thing for the industry is that they might be like 6 months behind. Maybe the runner-up would be 6 months behind, and then like the next in place, the third place will be like a year behind or something. And that doesn't really matter right now, but during the intelligence explosion, when the AIs are doing all the research and they're getting superhuman with AI research and so forth, a 6-month gap is a huge gap. If the second place company has just managed to get to the point where they can automate all their research, but the first place company has been doing that for 6 months, then I think they might have qualitatively quite more advanced capabilities, such that if they wanted to abuse their power and, for example, use their AIs as lobbyists or using persuasion or maybe some hacking or something, they could effectively cement their lead on everybody else. And how would this look? Well, it's hard to speculate. But one thing I'm concerned about is the race between the US and China. I think that it's going to get very intense. I think that there's going to be, President Trump and Premier Xi, and they're going to be staring each other down with nuclear missiles and stuff like that. Everyone's going to be arguing about what to do about these AIs. The AIs are going to be giving advice to the presidents about what to do. And even if we assume that the AI alignment problem is solved, I'm just quite worried about the decisions that these powerful people in control of these artificial workforces or armies could do. Yeah, that's the summary of my views. Now, how much time do I have left?
2 minutes where you
Great.
guys ask questions.
Yeah, so there's a lot to talk about. I think maybe one crux, I'll try to put some possible cruxes on the table as like pointers for future discussion. So it seems like we probably have some sort of disagreement about like the pace of progress, if that makes sense. You did say like, yeah, the benchmarks are going to go up a lot. So I'm not entirely sure where our disagreement is, but I imagine you'd get off the boat on my story, or like if you were to tell your own version of the story, it would start to diverge at some point. And I'm extremely curious to hear like how your story would diverge, and if you could spell all of that out. And with respect to your policy recommendations, I think relatedly, I am concerned that an extreme concentration of power is sort of the default outcome, even if we have no regulation whatsoever, and even if we encourage with open source releases and stuff, we're still going to end up in a situation where one company basically gets there first. And maybe if it's not one company, it'll be like one nation, like the United States versus China or something like that. So I'm interested to talk about that. Yeah, I think I'll stop there for now and say that the main thing I'm most excited to hear from you is your own story, basically. Like, maybe it's the same as mine up to some point and then it diverges. And I'm curious to like see it play all the way out.
Perfect.
Great. Now we're going to move to just an open discussion. Can we have some tapping in a sec? And if you want to put questions, then if the discussion runs, we might do questions. We might not. We'll see how it goes. But anyway, some clapping for the two speakers, and then they can chat.
Someone should take a photo of Daniel with AI as normal technology in the background. Yeah, I'm actually very excited to talk about the specific divergences a lot more. I mean, on the policy front, I think we actually might have more in common than I would have thought before the debate.
I totally agree with your claim, by the way. Like, we should all agree on this. I'm like, yes, we all agree on that.
Awesome. So I think like the place where we diverge is how quickly we get to the point where we can have these systems that are like broadly sort of good across the sort of slate. And that's probably because I'm like much less optimistic about these benchmarks corresponding to any sort of real world progress that is general. So I do think that like advances on frontier math or all of these benchmarks will be very, very quick, much quicker than some AI researchers might still anticipate. And that it tells us nothing about the AI's ability to persuade people, for example, to act against their interests. It tells us nothing about AI's ability to forecast specific outcomes. And of course, these methods have been getting more general, but solving any particular benchmark often does not depend on this generality. And like to put another note on that, I think even if we get to systems that are like, this next generation of systems that solve all of these benchmarks much better than today's systems would, you can't actually do that for most of the applications that involve real world consequential decisions because we are not rushing to employ these applications in the real world. Similarly, because of like the way we sort of do not automatically put out self-driving cars on every single street in the world.
Yeah. So let me think about that. So I totally agree that like I expect there to be a system that crushes frontier math sometime in the next like 2 years. And I don't think that system by itself will be like amazing at politics or persuasion. And my story there would just be like, well, it probably hasn't been trained to do good politics and persuasion, but it has just been trained to do a ton of good math, right? So I'm totally with you on that. I do think that eventually, once you have, broadly superhuman AI researchers and they've like allowed to cook for a few months or maybe less, then they can perhaps get to new paradigms or at least much more optimized AI designs that require less data to get to the same level of performance, or other words, like generalizing farther and faster. And so then I think you could potentially get the persuasion and the strategy and so forth, not like out of the box, but like it'd be the sort of thing where you could just direct your army of AGIs. I want you to train yourselves to be good at persuasion. And they're like, well, we're genius AI researchers. We've already discovered new paradigms of data efficient learning and online learning and stuff like that. We still need to like actually do the training run, but like we can do it much faster and with much less data than you would have thought possible. An analogy I would say here is for human scientists, right? Like humans can get good at stuff with only a few years worth of experience, right? And so I think at least in principle, it'd be possible to design an AI that can also get very good with only a few years worth of experience, except that you can have that experience perhaps spread out over like lots of parallel copies, So yeah, I don't know. But
interesting. So, I mean, maybe I can give an analogy of the way I'm sort of thinking about this, which is the development of vaccines. So with the COVID-19 pandemic, the development of the mRNA vaccine took 2 days. Like 2 days after we had the genome, we had the vaccines available. And yet the process of rolling it out in the world, testing whether it works well and so on, has that speed limit of, you have to do these tests. This is where humans come into the loop. I expect there to be similar sort of limitations when it comes to AI systems that you're targeting for any social outcome, not just persuasion, but anything that you might want to test.
Yeah.
And so that's the speed limit that I'm thinking about that we run into, irrespective of whether it's a human developing a vaccine or an AI.
Okay, let's talk about that. Or actually, I want to get my original thing, which is your story.
Okay.
So let's just play out your story in as much detail as you can spare for us. Just gratuitous detail, like so. Let's say 2 years from now, frontier math crushed. When do you think you'll get to the point where they can like basically automate research engineering? Like I said, the first milestone I mentioned.
So I think it's hard to say like what automating research engineering means in the same way as it is hard to say what automating writing code means. Like from the perspective of someone in the 60s, we have fully automated code creation. We're writing code perfectly well. And that's the way I expect things to go with research engineering as well, is you have systems that can go out and sort of solve entire sort of maybe sort of underspecified tasks related to research engineering. And then you have like 100 copies of these. But the task that a research engineer solves now is not the task of writing code to test a specific hypothesis. It is to decide between competing priorities, maybe making value judgments, maybe figuring out what the higher level goals are, and so on. And so, the research, there is no world in which we have automated research engineering as a field, because what a research engineer does is conditional on the technology available to the research engineer at the time. And at that point of time, we would already have like research engineers who are trained to use these armies of what we would today call like coding agents, sort of direct them, like, figure out what the most optimal use of the time is. You would still have performance reviews for these research engineers. Like that's the sort of key distinction I see this being, right? Like they have their own objectives that are sort of at a higher level of adaptability to whatever specific tools they have access to.
Yeah, so you mentioned this earlier, and I think it's an important point to understand, is that there's been this whole history of new technologies coming out, and people basically, like, as parts of their job get automated, their job changes, and they like focus more on the things that haven't been automated. And then as a result, you get this sort of thing where like the research engineer role, probably like basically everything that someone in 1960 would have done in that role has now just been completely automated. So it's sort of like a ship of Theseus sort of thing, where like pieces of the role keep getting automated, but then new pieces getting added, such that, right. So I'm totally with you on all of that. So then perhaps to like be more precise in terms of our definitions, we could say something like, when will there be some sort of AI agent system that can do everything that the research engineers currently do?
I see. I think it's hard to like put a number on it, and I'm not a super forecaster like many people in the room. But I would say that, we could get to these systems in the next decade or so, where you have like systems that are performing many of the coding tasks, many of the individual tasks that humans often do. Of course, not the tasks related to sort of reasoning about what are the values that go behind certain research projects, or figuring out what the alignment is between their vision and other people's vision, sort of mediating between that. So that's not like that is something that a research engineer does today, which I don't think is part of this vision, right?
No, I mean everything that they're doing today.
Then like if you literally mean every single thing that a research engineer is doing today, then I would say,
job. I mean, maybe they go dance too, but like I mean like maybe one way of putting it is like, consider someone who's a research scientist who has several research engineers reporting to them at a company such as OpenAI. Imagine an AI system such that that scientist would be happy to like have their current employees laid off and instead have access to that system. Because like they wouldn't be really missing anything important to actually their work. I mean, maybe they'd be missing out on some social aspects. Maybe they wouldn't be able to play board games with them afterwards. But like, as far as their work is concerned, they have. Oh, actually, it's probably also pretty good at board games too. But like, as far as their work is concerned, like it's going faster. In fact, or like there's nothing important missing there. Does that make sense as a sort of like concrete, definite thing to sort of forecast? Like, it's true that realistically, by the time that AI system exists, they won't actually fire those employees, because those employees will have moved on to other tasks that maybe the AI system can't do. But like,
so maybe I think what would help is like precision on the question in terms of a historical analogy. So when do you think this happened from the shift from, writing in binary versus like programming in Python or whatever?
So I don't know enough about the history of coding, but I imagine that this has happened several times over the course of history, at least probably for the research engineering role. Yeah, I don't know. I wouldn't be surprised if it's sort of like every 2 decades you've done the complete ship of Theseus thing, where like everything that they did 2 decades ago has been automated. That said, I also wouldn't be surprised if there are some things that just actually have stayed the whole time, such as you were saying something about like, truly understanding the intent of, the vision or something and then translating it into code. Like maybe there's some element of that just actually hasn't ever been automated before, but is about to be, I think. I'm not sure, but yeah.
Suggestions.
Yeah.
What about like horses, stable boys, elevator operators? It just has examples of jobs that have been switchboard operators.
Dock hands.
Right.
Yeah, so
She said there are some jobs that just have been completely automated, like elevator operators and like dock hands or whatever. Horses have been completely automated.
yeah, so I think maybe it will be like of a similar time scale. If it is literally sort of the aspects of the job, it will be like a decade or two.
Right. Okay. So then that's our big divergence already. Is that I'm expecting much faster progress in terms of that. I think that.
But does that qualitatively change the picture?
Well, maybe that part by itself doesn't, but then the next part does. I mean, right, so I think that the automated research engineer by itself isn't going to change the world. Automated research scientist maybe by itself won't change the world, but it will massively accelerate the science, especially the AI science. And then I think that thing, the result of that, will massively change the world.
Yeah, so I think this is the fundamental disagreement in some sense, right? Like, so the fact that you can get to a point where this sort of self-improving, recursive self-improvement in these AI systems leads to a broadly sort of, superhuman architecture for intelligence. And I think we have no evidence for that. This is a red flag, according to Scott. But I actually think that is where we disagree most. I don't think this will happen, is a more precise statement.
Would it be fair to say you think we're not going to get AGI then? Like by the definition that I gave earlier, where it like is as good as the best humans at every cognitive skill? Are you just like, we're not going to get that?
So I think like maybe we'll get AGI, but I think for all intents and purposes, for the purposes of discussing this now, it's like if we were discussing what industrialization would lead to in the 1600s. So we don't have the architecture, we don't have the ability to sort of think about what sorts of control we need in a world where we do get to AGI when we are so far. It's like thinking about what RLHF would mean, back in the 1900s, right? Like, so when we were faced with these models that we wanted to align for product safety reasons, very much so in this case, because OpenAI wanted to sell these tools to the public, we did figure out ways to control them and steer them. Actually, I also have a question for you, but whenever you're done with the response.
Okay, let me think of a response. Well, I do feel like we have a quantitative difference that I kind of just want to like verbalize. Like, I think that maybe in 2027, maybe in 2025, maybe in 2029, there will exist a system which is like the current, Claude computer using agent, except better in a bunch of ways. And in particular, so much better that it is as good as the best humans at every cognitive skill. And you definitely don't think, you're like, no, it's not going to happen for...
Yeah, I think there will be a jagged frontier. So it will be much better than current humans for a lot of things. I completely concede. But I don't think it will be like uniformly better in the same way that you might expect it to. So I think it won't be like great at, but like performing certain sort of common sense tasks in the world. It won't be great at determining which values or systems of beliefs to sort of align itself with. It won't be great at persuading people to behave against their interests in the same way.
Mm-hmm. What about if we restrict the domain of cognitive skills to those that are relevant to doing AI research? Would you also say it's not going to be able to do all of those skills, or would you say maybe it can do all of those, but not like values or something?
So I think, again, with AI research, it depends on where along the ladder you are. So in my view, AI research in terms of improving methods, great. But when it comes to like using these methods for applications that are useful in the real world, there are these speed limits. There are these sort of breakthroughs that no amount of AI research can sort of accelerate. And so those safety critical domains, but also like other sorts of real world domains where you have these interactions with real world institutions, that puts a speed limit on how much we can improve AI research with a view towards sort of improvement in that domain.
So the speed limit thing I think is conceptually separate from the capabilities thing. So
I think this is, again, like a fundamental difference. I don't think so. I think we have to have systems that can sort of interact in like real world or lifelike simulations of what we want to do in order to get systems that are like improving automatically in that domain. There has to be this feedback loop, which is, I think, like a point of disagreement. So I do think we'll continue to get better and better math and code models. And that's precisely because we have these environments, these sandboxes, where there are no speed limits to the improvements of these systems. But we can't get to better and better models of persuasion because we don't have good enough simulations of how real humans interact. And if we did have these simulations, or if we did have simulations of, let's say, even developing vaccines, like is another thing, right? If we did have sort of real world simulations of how to sort of bridge that gap, I think that is a scenario where I do think we will continue to get improvements. But for a lot of these social systems, we actually don't. There is no way to sort of collect this amount of information that is required to improve on this domain.
So
of tasks.
forget the persuasion and stuff for now. I agree that seems to require some actual interaction with humans, at least for now. What about just the AI R&D tasks? So all the tasks that are relevant to doing AI research, do you think that, would you say the same thing, like there's going to be these speed bumps or speed limits that slow things down?
If you want your AI to persuade people, then yes.
Okay, here's, you want to help me out?
Proposed operationalization. Can you talk about just the parts of OpenAI you want to care about? Like maybe you're like, make a new version of ChatGPT, not even talking about deploying it, just like a version of ChatGPT that's better. Because I'm worried that you're like, you can't automate AI progress, by which I mean self-driving cars. And Daniel's like, well, but you can automate AI progress, by which I mean making better foundation models. And
Yeah,
like,
I'm thinking things like coming up with new AI paradigms that are much more data efficient, for example.
Right, but in what sense is the model better if it can't perform tasks besides AI research?
So my story is like, first you automate the AI research, then you get much better AIs.
What does it mean to get better AIs?
For example, much better data. Thank you. That's actually really helpful. That's it. I think that's what I've been missing.
Yes.
Take data efficiency, for example. Like humans seem to be able to learn, some humans at least, like the really good ones, seem to be able to do like a year of some profession and then pick it up and be like really good at that profession. Whereas currently our like ML, RL training methods and stuff, they're more janky, you need a lot more data than that, etc. So like one important AI research dimension is like improving our methods for data efficiency so that we can have an AI that can just go do a profession for a year and then be a professional at it. And then improving it further still so that you don't actually have to spend doing a profession for a year. You can just make 1,000 copies of the AI and have them each do the profession for a day, accumulating 1,000 days of experience total. Like maybe that's possible too. And if you do enough AI research, you can get that implemented. And then boom, you still don't have the system that actually can do the persuasion or the whatever it is. But now you have a system that can learn to do it really fast.
So I agree that if we were in a world where sort of AI is omnipotent and can kill us all, then we should be concerned that AI is omnipotent and can kill us all. But I think that's the fundamental disagreement. I don't see us getting to a paradigm where you can have this sort of general purpose learning capability incorporated without actually in a sort of, interacting with the system at hand.
I didn't say it wouldn't interact. I said like the data efficiency is improved. So
I don't think you can get to AI systems that are data efficient at persuasion without having built these systems to become data efficient at persuasion.
And you
So
think
you're
that
saying there's no like general purpose. You're saying that you are skeptical that like training data efficiency on chess and math and code would lead to a learning algorithm that would also work on persuasion and biology.
That's a much better way of putting it. Yes, exactly.
Someone just repeat that for people who couldn't hear.
So Ajay said, I'm skeptical that developing learning efficient algorithms that work for math and code would lead to learning efficient algorithms that also translate to self-driving or persuasion or whatever.
And a question from the room sort of is like, is there evidence that you could you think of an example of something you see in 1 year or 5 years, short of exactly the case that Daniel gives, that would really change your view on this?
I mean, if we see systems that are data efficient across a broad range of tasks.
Anything before that?
I think it's hard to say. I think if we do get to systems that, for example, can persuade people to act against their interests is one example. If we start to see systems that can make predictions about or forecasts that are better than what humans can make with access to simple automated tools, that's another example.
What about baby LLM?
Go again?
Do you know the baby LLM?
I don't think I do.
Oh, it's a challenge for anyone to come up with an architecture that can learn to be GPT-2 level competent using as many words as a human child sees.
Interesting.
So would that be does that feel?
if that gets crushed, would that be evidence?
So I think, again, this is an example of a benchmark, right? So for all of these benchmarks, I think we can have shortcuts that we use our inductive knowledge or whatever, our experience in the world to code. So maybe a system that's not designed to do that, doing that, for instance, would be an example.
Okay.
Maybe I can ask a couple of questions of you, sorry, and then we can get to the audience question. So one thing I don't understand is why the story about 6 months or being 6 months or a year behind matters so much if you still think the world will be the same for some period of transition shifts where we're not applying these models in the real world. If we aren't applying these models in the real world, then what difference does that make?
So there's good, like there'll be like a political conflict, power struggle, and perhaps being 6 months advanced during this period will enable you to win the political power struggle. An example of what this might look like is, imagine it's 2027. Company A is 6 months ahead of Company B. They're both U.S. companies. Company C is 6 months behind them both, and Trump's getting quite concerned about all this AGI stuff, beating China, etc. Some conversations happen behind the scenes, and then they nationalize, make the Manhattan Project, and they take all the compute from all the companies that aren't in the lead and give it to the company that is in the lead, because of course they're in the lead, like they have the best algorithms and the best people and so forth. And so now they are just like the model company that has all the relevant compute. That's like a mini example of sort of like winning a political conflict and a way in which it helps to like have that lead. And in fact, that example didn't rely on using the AIs at all. It just didn't rely on like, ordinary politics. But you can imagine that it helps to also have the AIs giving you strategic advice on who to talk to and when and how and so forth, which again, they might not be good at by default, but perhaps you could tell them to quickly get good at it using,
Yeah, that would precisely be my objection in the sense that, if is this recording going to be posted online?
I think plausibly,
Okay.
probably.
So you could imagine, like, if, say, company A has the ear of the current administration, then you would get to a point where it doesn't really matter which company is leading the race, right? So to me, it sounds like regular geopolitical or national security conflict. And I don't think AI has anything to do with it in some sense.
I think the conflict will be ongoing regardless of it. I'm saying that in a bunch of little ways, having the AIs might be used to help win the conflict.
You think it will be as if like a child is arguing with an adult, and the adult. I mean, you can
sure. Also, I don't want to over-index too much on the persuasion thing, but it's just one example of political conflict and a skill that might be relevant to it. So is that, keep asking me questions. If you had
No, I think I get it. So I think in the world where we do have AI systems that are broadly sort of better than humans at everything, I agree we should be very worried. I just think that's not the world where we get to if we sort of continue down this path. We get to a world where we do a lot of economically useful stuff for sure. We do a lot of really sort of useful, really scary things with the technology, but they are sort of restricted to these domains where we expect to make massive progress by just relying on simulations. So I think that is one key disagreement, and it's very helpful to have that.
Yeah. Got one audience question here. Model runs are neither free nor instantaneous. They take up the majority of time spent on AI development. Not all experiments succeed, nor is inference free. Why should we believe that an AGI researcher will be able to perform all experiments within such a short time?
Great question. So I'm not sure how fast things will go. It's literally my job right now to think about this. Shout out to AI Futures Project people. It was Thomas. Yeah. So, but I don't know. It's hard to predict how fast AI research will go in general, and then it's even harder to predict how fast it will go once parts of it have been automated and once all of it has been automated and so forth. It's true that there are these various bottlenecks, like running experiments, waiting for code to compile eventually, all this possible stuff, collecting data.
Building 5 gigawatt size data centers.
Indeed. Yeah. So I think that hopefully in a month or two we will publish some of our thinking on this. Yeah.
You would agree that if it is necessary to build new data centers, then you don't get superintelligence in 6 months.
Yes.
Totally. Yeah, sorry.
And
The
that's
superintelligence 6 month view relies on the assumption that we'll get vastly more efficient architectures through the process of automating the R&D.
That's
So
right.
the assumption is we'll get some new thing that's transformer plus that can learn dramatically more efficiently than humans.
That's right.
And
it's not an
doesn't
assumption.
I'm
require-
starting
Pretty
point of a
much.
human level AI researcher. I need
That's
to make sure that we add that. We need to
That's
be
right.
clear on this. Right?
Yep.
So we'll have some algorithmic advance that will cause us to be so much more efficient from a human level researcher.
That's right.
Doesn't it seem like we should be able to predict that from where we are then, given that the researcher is human level?
Will there be a million?
I am predicting that. What do you mean?
You have this very accelerated timeline to ASI, right? And the principle is exactly what was stated there. We'll find some sort of shortcut that will allow us not to need data centers, not to need power plants, etc.
Yeah.
Right? From the starting point of the human AI research. doesn't that imply that we'll be able to see that happening even without the AI that can be?
For example, MLA bench. How would you describe the loss?
Yeah, so let me say some more things. So first of all, algorithmic efficiency and data efficiency and all of these metrics have in fact been improving over the last decade. And like people try to estimate like how much of the overall AI progress came from scaling up compute versus from better ideas. And it's like roughly half and half. And so if you imagine that now you are massively accelerating the research, but you still have the same amount of compute, like you haven't built any new data centers yet, then, well, that at the very least cuts it by half in terms of like how much you can do the progress, but perhaps you can compensate and just get a lot of augmented progress. You know, maybe you can get 5 years of augmented progress, for example. Think about how much, think about for the same amount of compute right now, what sort of language model we can train compared to the state-of-the-art language models 5 years ago, and it's like way better. So like holding compute fixed, our algorithms have just gotten better, right? So, I mean, one thing is just that even without constructing new data centers, there'll be tons of like tiny little improvements that add up to massive algorithmic efficiency gains. The other thing I would mention is human brain.
We're going to have to cut. I'm going to allow you 30 seconds. You haven't spoken recently, so 30 seconds of comment on anything.
All right, let's see. Yeah, I think it was very helpful. We have the key points of disagreements. I think my pitch to this room is if you agree on the first bucket and maybe even on the second bucket, we should work together regardless in making sure that we do these things.
I agree with that.
Great. If we'd like to clap our speakers in a moment, but before we're going to clear out very quickly afterwards because we've got another talk here, which is Flo. Is it Flo Perello and Richard No speaking? And are you two free after this? Maybe you could go out the back and we'll close that door so that people won't be interrupted. But if you all pile out the back if you want to keep talking to them, and pile out the front if you don't. Okay, thanks so much. Big round of applause.